Now, in this lecture, we will find the radius of the small circle. In the drawing, we have a quarter circle. We know that angle BCD, this angle is equal to 90 degrees. Chord CD equals to 2 units. DO equals to 3 units. And inside the quarter circle we have this small circle, and we want to find out the radius of this small circle. First of all, we have a quarter circle, therefore DO is the radius of the quarter circle, so I will mark it as R. DO is the radius of the quarter circle. I will mark it as capital R, and because of the fact that we have a quarter circle, actually angle DOB must be equal to 90 degrees. Okay? Again, in a quarter circle, DO is actually the radius of the quarter circle, and also this line segment is also the radius of the quarter circle, and angle COB, this angle is equal to 90 degrees. Okay? And we will define the center of the small circle as point P. This is the center of the small circle, and P is the center of the small circle. Then we will join together points A and P by a straight line. And we also will join together points P and B by a straight line. We will define the touching point between CB and the small circle as X. And then we will join together points P and X by a straight line. Actually, PX is the radius of the small circle because of the fact that it starts from the center of the small circle and ends at point X, that is a point on the circle, on the small circle itself. Therefore, it is the radius of the small circle. I will mark it as small r. And from the same reason, AP is also the radius of the small circle. So I will also mark it as small r. And I will define angle ABP, this angle as theta, and actually OA is tangent to the small circle and AP is the radius. So the radius and the tangent to the radius are perpendicular to each other. So if we have a a circle and we have tangent if AB is tangent to the circle at point B, and we have radius at point B, then the radius and the tangent to the circle are perpendicular to each other. That is to say, this angle is 90 degrees. Okay, and this angle also is 90 degrees. Therefore, we have here OA is tangent to the small circle. OA is tangent to the small circle, and we have the radius and the tangent to the radius and the tangent to the circle. The radius is perpendicular to its tangent, that is to say, this angle is equal to 90 degrees. Okay, so actually triangle ABP is a right triangle, and angle ABP equals to theta. So we can write down that tangent theta equals to AP over AB. Okay, tangent theta equals to AP over AB. But we know that AP is the radius of the small circle, so we can substitute AP by R. So tangent theta equals to R over AB. We will multiply this equality by AB, and we will get that R equals to AB times tangent theta. Okay, R, the radius of the small circle that we want to find out, the size of it, the radius equals to AB times tangent theta. So in order to find out the radius of the small circle, we must find AB and tangent theta. Okay, so I will draw again triangles ABP and triangle PXB, and we will prove that those two triangles are congruent to each other. Okay, so triangle ABP So I drew again triangles ABP and triangle PBX. So on those two triangles, we know that AP equals to R and PX is also equals to R. So actually AP equals to PX, and both those two line segments are the radiuses of the small circle, therefore they are equal to each other, and PB is a common side. It belongs both to triangle ABP and PB also belongs to triangle PBX. So PB equals to PB. It is actually a common side. It belongs to both triangles. Common side. And AB equals to BX according to two tangents theorem. Okay, AB equals to BX according to two tangents theorem. Two tangents theorem. Actually, two tangents theorem states that the lengths of two tangents from a common external point to a circle are equal. So I will read the two tangents theorem again. The lengths of two tangents from a common external point to a circle are equal. Okay, so actually we have tangent OA and tangent BX. Both those two tangents, we have tangent AB, we have tangent AB and tangent BX. Both those two tangents, tangent AB and tangent BX, exiting from a common point, that is to say from point B, and tangent AB is tangent to the circle at point A, while tangent BX is tangent to the circle at point X. So actually we have two tangents that exiting from a common point, that is to say from a common B, and touching the circle. So according to two tangents theorem, the lengths of those two tangents are equal. So AB equals to BX. Okay, so actually we proved that all the sides of triangle PBX congruent to all the sides of triangle PAB. Therefore, those triangles are congruent to each other according to side rule. Okay, so I write it down. Triangle ABP is congruent to triangle PBX according to side rule. Side rule says that if two triangles has three sides of, if one triangle has all of its three sides congruent to all the three sides of another triangle, then those two triangles congruent to each other according to side rule. Okay, so we actually proved that those two triangles, triangle PBX and triangle ABP, congruent to each other according to side rule. Therefore, we can deduce from it that angle ABP in triangle ABP, angle ABP is equal to angle PBX. PBX in triangle PBX. Okay? Angle ABP in triangle ABP equals to angle PBX in triangle PBX according to the rule that corresponding angles in congruent triangles in congruent triangles are equal to each other. Again, we proved that triangle PBX is congruent to triangle PBA. From that fact, we can derive that angle ABP is equal to angle PBX according to the rule that corresponding angles in congruent triangles are equal to each other. Okay, so actually we know that angle, according to our definition, angle PBA is equal to theta, so angle PBX will be also equal to theta because those two angles are equal to each other. In the next step, we will extend CB and DO until they intersect each other at point E. Okay, we will extend line segment CB and line segment DO until they intersect each other at point E. Point E is the intersection point between chord CB after we extended it, after point E is the intersection point of line segment CB after we extended it, with line segment DO after we extended also line segment DO. Actually they intersect each other at point E, or you can also say that they touch each other at point E. Okay? And actually it is given us in the question that angle BCD equals to 90 degrees. But angle BCD that equals to 90 degrees is actually peripheral angle. Angle BCD that equals to 90 degrees is a peripheral angle. Okay, again, angle BCD that equals to 90 degrees is a peripheral angle. And we have a rule that states that any peripheral angle that equals to 90 degrees rests on the diameter of the circle. I will read the rule again. The rule states that any peripheral angle that equals to 90 degrees rests on the diameter of the circle. So we know that peripheral angle DCE equals to 90 degrees. So we have here peripheral angle that equals to 90 degrees, and according to the rule that I read 1 minute ago, any peripheral angle that equals to 90 degrees rests on the diameter of the circle. Peripheral angle DCE that equals to 90 degrees rests on DE. So DE is the diameter of the quarter circle. We can derive from this rule that DE is the diameter of the quarter circle. peripheral angle DCE equals to 90 degrees. And we have a rule that any peripheral angles that equals to 90 degrees rest on the diameter of the circle. So peripheral angle that equals to 90 degrees rests on DE. Therefore, according to that rule, DE is the diameter of the quarter circle. And we know that the diameter of any circle equals to 2 times the radius. So DE equals to 2R, to 2 capital R. DE equals to 2 capital R. And we know that DO equals to R. So, and DE equals to 2R. Okay? DE equals to 2R because it is the diameter of the quarter circle. And we know that TO equals to capital R. So, OE, the size of OE will be the 2R, that is the size of DO, minus 2R, that is the size of DE, minus DO. So it is actually 2R minus R, that is R. So OE equals to the radius of the quarter circle, and we know that R equals to 3, so R equals to 3. You can write here that R equals to 3. Okay? So the diameter of this quarter circle is actually equals to 2R, that is 3 plus 3 is 6 units, and the radius of this quarter circle equals to 3 units. Okay, so in the next step we will complete the quarter circle to a semicircle. Okay, we completed the quarter circle to a semicircle, and we know that DE is the diameter of this quarter circle and also the diameter of the semicircle. So DE is the diameter of the quarter circle and the semicircle. DE is a straight line. DE is a straight line. And we have the rule that states that the sum of the angles on a straight line is equal to 180 degrees. The sum of the angles on a straight line is equal to 180 degrees. Okay, we read the rule again. The rule states that the sum of the angles on a straight line is equal to 180 degrees. So, because of the fact that DE is a straight line, if you focus at point O on the straight line DE, the sum of the angles at point O on the straight line DE must be equal to 180 degrees. And at point O we have one angle that is a right angle, that is to say it equals to 90 degrees, plus the size of angle EOD, the size of this angle EOD, EOB, 90 degrees plus the size of this angle EOB, must be equal to 180 degrees according to the rule that I stated. Okay, 90 degrees plus angle EOB must be equal to 180 degrees. So here we can subtract 90 degrees from this equality, and we will get that angle EOB equals to 180 degrees minus 90 degrees is 90 degrees. So angle EOB is a right angle because it equals to 90 degrees. Okay, but okay, if angle EOB is a right angle, then triangle EOB is a right triangle because it has one angle that equals to 90 degrees. So this triangle EOB, is a right triangle. Triangle EOB is a right triangle, but before I relate to triangle EOB, here we have two vertex angles. Angle EBO, this angle is a vertex angles, angle, and angle ABC is also a vertex angles. So angles EBO and angle ABC are two vertex angles. Okay, angle EBO and angle ABC are two vertex angles. Maybe I will draw them again in order to see it clearly. Angle ABO or AO intersects with CE. Actually, angle EBO and angle ABC are two vertex angles, and we have a rule that states that vertex angles are equal to each other. Again, vertex angles are equal to each other, therefore angle EBO equals to angle ABC. According to this rule, angle EBO is equal to angle ABC because there are two vertex angles. Okay, but what is the size of angle ABC? Angle ABC, you can see from the drawing that angle ABC equals to theta plus theta. So angle ABC equals to theta plus theta. So we will get that angle ABC equals to 2 theta, that equals to also to angle EBO, that also equals to 2 theta. So this angle EBO, equals to 2 theta. Okay? So now we will return to the right triangle, triangle EBO. So in the right triangle, triangle EBO, we know that the sum of the angles is equal to 180 degrees. So in triangle EBO, the right triangle, triangle EBO, the sum of the angles is equal to 180 degrees. That is to say, this angle that is 90 degrees plus 2 theta plus angle BEO equals to 180 degrees. Again, the sum of the angles in triangle EBO equals to 180 degrees. So here we will substitute 90 degrees from this equality, and we will get that 2 theta plus angle BEO equals to 180 degrees minus 90 degrees is 90 degrees. So we got that 2 theta plus angle BEO equals to 90 degrees. Here we will subtract 2 theta from this equality, and we will get that angle BEO equals to 90 degrees minus 2 theta. Okay, angle BEO equals to 90 degrees minus 2 theta. So here we can write that this angle equals to 90 degrees minus 2 theta. In the next step, we will focus on the right triangle, triangle CDE. So in the right triangle, triangle CDE, we know also that the sum of the angles in the right triangle CDE equals to 180 degrees. So we can write down that angle CDE plus this angle that equals to 90 degrees plus this angle that equals to 90 degrees minus 2 theta the sum of those three angles must equal to 180 degrees. This equality states that the sum of the angles in the right triangle CDE equals to 180 degrees. So actually here we have 90 degrees plus 90 degrees is 180 degrees. So we have 180 degrees in this side of the equality and we have 180 degrees on the other side of the equality. So 180 degrees will get cancelled. And what is left after we cancel the 180 degrees? What is left is that angle CDE minus 2 theta equals to 180 degrees. So here we will add 2 theta to this equality and we will get that angle CDE equals to 180 degrees. Actually we cancelled 180 degrees in both sides of the equation, so actually here we have 0 because 180 degrees is cancelled. Okay, 180 degrees in this side of the equality is cancelled, so what is left here is 0. So we have angle CDE minus 2 theta equals to 0. So we added 2 theta to this equality and we got that angle CDE equals to 2 theta. Okay. So we found out that angle CDE, this angle, equals to 2 theta. Okay. So we will continue to focus on the right triangle CDE. According to the Pythagorean theorem, in the right triangle CDE, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, CD square plus CE square equals to DE square. Again, in the right triangle CDE, according to the Pythagorean theorem, CD square plus CE square equals to DE square. But what is the value of CD? CD equals to 2 units. It is given us in the question. So CD square is 2 square, 2 square is 4, plus CE square equals to DE square. What is the size of DE? DE equals to 2R, that is to say it equals to 3 plus 3. DE equals to 6, so DE square is 6 square, 6 square is 36. So in total we got that 4 plus CE square equals to 36. Here we will subtract 4 from this equality and we will get that CE square equals to 36 minus 4 is 32. So here we will take a root out of this equality and we will get that CE equals to the root of 32. And 32 equals to 16 times 2. And the root of 16 times 2 is actually the root of 16 is 4 times root 2. So we got that CE equals to 4 times root 2 units. CE equals to 4 times root 2. Okay? And again, in the right triangle CDE, tangents 2 theta equals to CE over CD. Okay, in the right triangle CDE, tangents 2 theta equals to CE over CD. But we have already found out that CE equals to 4 times root 2. And CD equals to 2 units. It is given us in the question. So in total, we got tangents 2 theta equals to CE over CD, CE equals to 4 times root 2, and CD equals to 2. So 4 times root 2 over 2, 4 over 2 is 2. So we get here that 2 times root 2 is the value of tangents theta. Okay, we can write here that tangents 2 theta equals to 2 times root 2. Okay. Tangents 2 theta equals to 2 times root 2. In order to find out the value of the radius of the small square, we actually found out that the radius of the small square equals to AB times tangent theta. So, in order to find out the radius of the small circle, we must find out the value of tangent theta and the value of AB. So, here what we found is the value of tangents 2 theta, and we need the value of, not the value of tangents 2 theta, but the value of tangents theta. So in order to find out the value of tangents 2 theta in order to find out the value of tangents theta from tangents 2 theta, we will use a special trigonometric identity that will help us to find out tangents theta from tangents 2 theta. The trigonometric identity is tangents 2 theta equals to 2 tangents theta over 1 minus tangents square theta. Okay, we will use this trigonometric identity that tangents 2 theta equals to 2 tangents theta over 1 minus tangents square theta. And from this trigonometric identity, we will find out the value of tangents theta. Okay, so we know that tangents 2 theta equals to 2 times root 2, so we can substitute tangents 2 theta in the trigonometric identity by 2 times root 2. Okay, so we write that tangents 2 theta is 2 times root 2. Here we have equals to 2 tangents theta over 1 minus tangent square theta. Okay, so here we will define tangent theta as x, and it will be easier for us to solve this equality by defining tangent theta as x. Okay, so we will get that 2 times, so actually tangent theta equals to x according to our definition. So we'll substitute tangent theta in this equality by x, and we will get that 2 times root 2 equals to 2 tangent theta. Tangent theta is x, so 2 tangent theta is 2x over 1 minus tangent square theta is actually x squared. So we got that 2 times root 2 equals to 2x over 1 minus x squared. Here we will cross multiply this expression, and we will get that 2 times root 2 times 1 minus x squared equals to 2x. Here we will divide this equality by 2, and we will get that root 2 times 1 minus x squared equals to x. We will subtract x from this equality, and we will get that root 2 times actually we will open the brackets here. Instead of subtracting x, we will open the brackets, and we will get that root 2 times 1 is root 2 minus root 2 x squared equals to x. So here we will add to this equality root 2x squared, and we will get that root 2 equals to root 2x squared plus x. Here we will subtract root 2 from this equality, and we will get that root 2x squared plus x minus root 2 equals to 0. So we got quadratic equation we know that the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. So that is the general formula for a quadratic equation when a, b, and c are the coefficients of this quadratic equation, and x is the variable that we want to find out. And in order to find out the value of x, we have a special formula that we will use. So the solution for x, or the equation for x, is x equals to minus b plus minus root of b squared minus 4 times a times c over 2a, when a, b, and c are the coefficients of this quadratic equation, and x is the value that we want to find out. So in our specific quadratic equation, root 2 x squared plus x minus root 2 equals to 0, the coefficient of our specific quadratic equation is a equals to root 2, b equals to 1, and c equals to minus root 2. So in order to find out the value of x, we will substitute a, b, and c that we found out by a, b, and c, the general formula for x. So x will be equal to minus b. We know that b equals to 1, so minus b is minus 1 plus minus root of b squared, b is 1, so b squared is 1 minus 4 times a is 4 times root 2 minus 4 times root 2 times c is minus root 2, all divided by 2 times a. 2 times a is 2 times root 2. So we got that and we found out that x equals to minus 1 plus minus root of 1 minus, first of all, minus times minus is plus, and root 2 times root 2 is 2, so 4 times 2 is 8. So we have 1 plus 8. 1 plus 8 is 9 over 2 times root 2. So in total we got that x equals to minus 1 plus minus root 9 over 2 times root 2. Okay, so root of 9 is 3, so I write it down that x equals to minus 1 plus minus root of 9 is 3 over 2 times root 2. The first solution to the for x is x equals to minus 1 minus 3 is minus 4 over 2 times root 2. As minus 4 over 2 is minus 2 over 2. So here x is less than 0, it is a negative number, but actually in the drawing we have right triangle, this right triangle we have, this is a right angle equals to 90 degrees, and here we have theta we know that the sum of the angles in any triangle equals to 90 degrees, so the biggest angle here is 90 degrees. Theta plus the size of this angle must be equal to 100 degrees, to 90 degrees, so theta is less than 90 degrees because the sum of the angles in any triangle equals to 90 degrees, to 180 degrees. So 180 degrees minus 90 degrees is 90 degrees, so angle theta plus this angle will be equal to 90 degrees. So angle theta itself must be less than 90 degrees. Okay, so theta is less than 90 degrees. When theta is less than 90 degrees, then tangent theta must be a positive number, tangent theta must be greater than 0. But here x that equals to tangent theta according to our definition is a negative number. But in our specific case, theta that is less than 90 degrees, then tangent theta must be a positive number. So the result is negative and theta must be positive. So tangent theta that equals to x that equals to minus 2 over root 2 is incorrect answer because tangent theta is negative, and here tangent theta must be a positive number. So tangent theta equals to root 2 over root 2 is incorrect answer. Is not possible, so we left only with the other solution that x equals to minus 1 plus 3 over 2 times root 2, and minus 1 plus 3 is 2 over 2 times root 2. 2 over 2 is 1 over root 2. So we found out that x equals to 1 over root 2. X equals to tangent theta according to our definition. So tangent theta equals to 1 over root 2. Okay? Tangent theta equals to 1 over root 2, and the radius of the small circle equals to AB times tangent theta, and we have already found out that tangent theta equals to 1 over root 2. So the only thing that is left to find is the value of AB. Okay? And we also found out that tangents 2 theta equals to 2 times root 2. Okay? Tangents 2 theta equals to 2 times root 2. So actually we will focus on the right triangle, triangle EBO. On the right triangle, triangle EBO, this right triangle tangents 2 theta equals to EO over BO. Okay? Tangents 2 theta equals to EO over BO. But we know that EO equals to 3 units. Is the radius of the big circle or semicircle. So EO equals to 3 over BO. And we have already found out that tangent theta equals to 2 times root 2. So 2 times root 2 equals to 3 over BO. substituted tangent 2 theta by 2 times root 2, and we got that 2 times root 2 equals to 3 over BO. Here we will multiply this equality by BO, and then we will divide it by 2 times root 2, and we will get that BO equals to 3 over 2 times root 2. Okay, BO equals to 3 over 2 times root 2. So here we found out that BO equals to 3 over 2 times root 2. Okay. In the next step, we will focus on the right triangle, triangle ABP. Okay, we will focus on this triangle, the small right triangle. So, according to the Pythagorean theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AP square plus AB square equals to PB square. No, actually we will focus on the right triangle, triangle APO. So on the right triangle, triangle APO, in triangle APO, the right triangle, triangle APO, the square of the hypotenuse equals to the sum of the square of the perpendiculars, that is to say AP square plus AO square equals to PO square. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay? AP square plus AO square equals to PO square. So here we will extend the hypotenuse PO until it touches this point, until it touches the two circles, until it touches the touching points of the two circles, that will be defined as point M. Point M is the touching point. Is the touching point between the small circle with the big circle, and it is actually also the touching point of the hypotenuse OP after we extended it it touches the two circles at point M. But what is MP? MP is the radius of the small circle because it exits from the center of the small circle and touches the small circle at point M. So MP equals to small r. And what is the size of OM? OM is actually the radius of the big circle, that is to say capital R. Because it exits from the center of the big circle, that is to say from point O, and touches the big circle at point M. So OM is the radius of the big circle, that is to say capital R. And what is the size of OP? OP equals to OM minus MP. OP equals to OM minus MP. Okay, OM minus MP. Okay. OP equals to OM minus MP. And we have already found out that OM equals to capital R and MP equals to small r, the radius of the small circle. So we can write down that OP equals to capital R minus small r. And we know that capital R, the radius of the big circle, is 3 units. So we will substitute R by 3 minus small r. So OP equals to 3 minus small r. Okay, OP equals to 3 minus small r. Okay, so we have AP square plus AO square equals to PO square. So what is the size of AP? AP is the radius of the small circle because it exits from the center of the small circle and touches the small circle at point A. So AP equals to R. And AP square is R square or small r square plus OA square equals to PO and OP is the same. PO square OP square, OP equals to 3 minus R. So OP equals to 3 minus R, so OP square will be equal to 3 minus R square. Okay, so we have this equality that R square plus OA square equals to 3 minus R square. R square plus OA square equals to 3 minus R square. So we will open the brackets in this side of the equality and we will get that R square plus OA square equals to 3 minus R square is 3 squared, that is 9, plus R square minus 6R. Okay, so we actually have this equality. So here we have R square in this side of the equality and we have R square on the other side of the equality, so R square will get cancelled. And what is left after we cancelled R square? We will have OA square equals to 9 minus 6R. So here we'll take a root out of this equality and we will get that OA equals to the root of 9 minus 6r. That is the value of OA. OA equals to the root of 9 minus 6r. And we have already found out that BO equals to 3 over 2 times root 2. BO equals to 3 over 2 times root 2. And what is the value of AB? From the drawing we can see that AB equals to AO minus BO. Again, AB equals to AO minus BO. So AB equals to AO minus BO. We have already found out AO and OA is the same. So AO equals to root 9 minus 6 over r, and BO equals to 3 over 2 times root 2. So we will substitute AO by root 9 minus 6r, and we will substitute BO by 3 over 2 times root 2. And we will get that AB equals to AO. AO is the root of 9 minus 6r minus BO. BO is 3 over 2 times root 2. Okay? So we have the value of AB, that is the value of AB. We have already found out that tangent theta equals to 1 over root 2, and we know that the radius of the small circle equals to AB times tangent theta. What is left to do is to substitute AB in this equality by this value, the value of AB here, and to substitute tangent theta by 1 over root 2. Okay, in this way we'll find out the radius of the small circle. So the radius of the small circle equals to AB. AB is root 9 minus 6r minus 3 over 2 times root 2 times tangent theta is 1 over root 2. Okay, so the radius of the small circle equals to this expression. Here we will multiply this equality by root 2, and we will get that root 2 times the radius of the small circle equals to root of 9 minus 6r minus 3 over 2 times root 2. Okay? So here we will add to this equality 3 over 2 times root 2. We will get that 2 times r plus 3 over 2 times root 2 equals to root of 9 minus 6r. Here we will multiply root 2r by 2 times root 2, and then we will divide it by 2 times root 2 in order to have a common factor with this expression. So we will get that root 2 times r times 2 times root 2 over 2 times root 2 plus 3 equals to root of 9 minus 6r. So here root 2 times root 2 is 2 and 2 times 2 is 4. So we have here 4r plus 3 over 2 times root 2 equals to the root of 9 minus 6r. So here we will square this equality and we will get that 4r plus 3 square over 2 times root 2 square is 8 equals to the square of a root. The square and the root cancel each other. Again, if we square this equality, we have square and the root, so the square cancels the root, and what is left is 9 minus 6r. Okay, so we got that 4r plus 3 square over 8 equals to 9 minus 6r. Here we will multiply this equality by 8 and we will get that 4r plus 3 square equals to 8 times 9 is 72, and 72 times minus 6r is minus 48r. So here we will open the brackets. 4r plus 3 square is 16r square plus 9 plus 4r times 3 is 12r. 12r times 2 is 24r equals to 72 minus 48r. Here we will add to this equality 48r and we will get that 6r square plus 9 plus 24r plus 48r is 72r equals to 72. Here we will subtract 72 from this equality and we will get that 16r square plus 72r minus 63 equals to 0. So here we have a quadratic equation. In this quadratic equation, a equals to 16, b equals to 72, and c equals to minus 63, and we have the solution for a quadratic equation is x equals to minus b plus minus root of b square minus 4 times a times c over 2a. That is the solution for the quadratic equation. In our specific quadratic equation, the variable x is actually equals to r, and a equals to 16, b equals to 72, and c equals to minus 63. A equals to 16, b equals to 72, and c equals to minus 63. So we'll substitute the coefficients a, b, and c that we found in this solution for x. So we get and x equals to r, so we substitute x by r. R equals to minus b. B equals to 72, so minus b is minus 72 plus minus root of b square. 72 square is 5184 minus 4 times A is 4 times 16 is 64 times 63 is 4032 over 2A is 32, so R equals to minus 72, and here we get that it is plus minus root of 9216 over 32, and we will get that R equals to minus 72 plus minus the root of 9216 is 96 over 32. Okay, so that's what we have, that the radius of the small circle equals to minus 72 plus minus 96 over 32. So the first solution is R equals to minus 72 plus 96 is 24. 24 over 32 is 0.75 or 3 over 4 units. So the first solution is that the radius of the small circle equals to 0.75 or 3 over 4 units. And we have also the second solution, that minus 72 minus 96 is minus 168 over 32 is minus 5.25, but the radius must be a positive number, R greater than 0, so this solution is incorrect solution. So the final answer to the question is that the radius of the small circle equals to 0.75 units or 3 over 5 units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the radius of the small circle. We know that the small circle is inside a quarter circle, and we know that angle BCD equals to 90 degrees, CD cos CD equals to 2 units, and DO equals to 3 units. And first of all, in a quarter circle, DO is the radius of the quarter circle, and this angle in any quarter circle is a right angle. So R, capital R equals to 3, and angle DO DOB equals to 90 degrees. Okay, and then we have triangle ABP. We focused on triangle ABP. Actually, we have BP is tangent to the circle at point BA is tangent to the circle at point A, and PA is the radius. So the tangent and the radius are perpendicular to each other. For that reason, angle PAB is a right angle, so triangle PAB is a right triangle. And in the right triangle PAB, we know that tangents, we defined angle ABP as theta, and in the right triangle ABP, we know that tangent theta equals to AP over AB, and AP is the radius, so tangent theta equals to R over AB. So R equals to AB times tangent theta. So in order to find out the radius of the small circle, we must find out the value of AB, and we must find out the value of tangent theta. Okay? So again, the radius of the small circle equals to AB tangent theta. And in the next step, we proved that triangle PBX is congruent to triangles PAB, because we have AP that equals to PX. Both those two line segments are the radiuses of the small circle, therefore they are equal to each other, and PB is a common side, so PB equals to PB, and AB equals to BX. AB equals to BX according to two tangents theorem. Two tangents theorem states that the lengths of two tangents from a common external point to a circle are equal. Again, the lengths of two tangents from a common external point to a circle are equal. So actually here we have, from point B, we have two tangents to the small circle, tangent BA and tangent BX. And according to the rule of two tangents theorem, those two tangents that exist from a common external point, that is to say from point B, are equal to each other. So BX equals to AB. So we actually proved that all the sides of triangle PBX are equal to all the sides of triangle ABP. Therefore, those two triangles are congruent to each other, and from the fact that they are congruent to each other, we can derive that angle ABP equals to angle PBX, and both those two angles are equal to theta, because angle ABP, angle APB equals to theta, so and the other angle that equals to it also will be equal to theta. Okay? And this is according to the rule that corresponding angles in congruent triangles are equal to each other. Actually, angle BCD equals to 90 degrees. It is given us in the question. And angle BCD is a peripheral angle. Angle BCD is a peripheral angle because it is inside the quarter circle, and we have a rule that any peripheral angle that equals to 90 degrees rests on the diameter of the circle. So we have peripheral angle BCD that equals to 90 degrees, and according to the rule that I read, the peripheral angle that equals to 90 degrees must rest on the diameter of the circle. So DE must be the diameter of the quarter circle according to the rule that I read. So if DE is the diameter of any circle equals to 2 times the radius. And so DE equals to 2R. And if DO equals to R, then OE must be also equal to R, because it must complete the sum of those two parts to 2R. So R plus R must be equal to 2R, because DE is the diameter that equals to 2R. So OE also must be equal to R. Okay, and we've already found that angle DOA equals to 90 degrees because it is a quarter circle, and we know that DE is the diameter of the circle, therefore it is a straight line, and we know that the sum of the angles on a straight line is equal to 180 degrees. So 90 degrees plus this angle must be equal to 180 degrees. 90 degrees plus angle EOB must be equal to 180 degrees. We subtracted 90 degrees from this equality and we got that angle EOB equals to 90 degrees. So this angle EOB, is a right angle, it equals to 90 degrees. Okay? And then, therefore, if angle EOB equals 90 degrees, the triangle EOB is a right triangle. Okay, but we have here two vertex angles. Actually, those two angles that I marked with the red line are vertex angles, and we have a rule that vertex angles are equal to each other. Okay, so here we have vertex angles, and according to the rule that vertex angles are equal to each other, they are equal to each other, and that is to say, angle EBO equals to angle ABC equals to 2 theta, because these vertex angles, with this vertex angle, angle ABC, equals to 2 theta plus theta. That is to say, it equals to 2 theta. So angle ABC equals to angle EBO equals to 2 theta. So these vertex angles equal to 2 theta. So in the right triangle EBO, we have 90 degrees, angle 2 theta. So the third angle must be equal to 90 degrees minus 2 theta. And we know that the sum of the angles in any triangle equals to 180 degrees. So the size of this angle plus 90 degrees plus 90 degrees minus 2 theta must be equal to 180 degrees. Okay, and after we solve this simple equality, we found out that angle CDE equals to 2 theta. So this angle, angle CDE, equals to 2 theta. So actually, triangle CDE is a right triangle, and according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, CD square plus EC square must be equal to ED square. Again, CD square plus CE square equals to DE square. But we know that CD equals to 2, so CD square is 2 square is 4. Plus CE square equals to DE square. DE is the diameter of the circle, of the quarter circle. DE is R plus R, 2R, and R equals to 3. So DE is 6 units, so DE square is 36. So actually, here we have 4 plus CE square equals to 36. We subtracted 4 from this equality, and we found out that CE equals to 4 times root 2. Okay, so in the triangle CDE, the big right triangle, tangents 2 theta equals to CE over CD. Tangents 2 theta equals to CE over CD. Tangents 2 theta equals to CE over CD, but we found out that C equals to 4 times root 2, and CD equals to 2, it is given us in the question. So tangents 2 theta equals to 2 times root 2. Okay, tangents 2 theta equals to 2 times root 2. And we know that the radius of the small circle equals to AB times tangent theta. So in order to find out the value of tangents 2 theta, I presented to you a new trigonometric identity that tangents 2 theta equals to 2 tangents theta over 1 minus tangents square theta. And we substituted tangents 2 theta by 2 times root 2, and we defined tangent theta as x. So we got a quadratic equation, and we found out that x that equals to tangent theta is actually equal to 1 over root 2. X equals to 1 over root 2. That is to say, tangent theta equals to 1 over root 2. So we made half the way, and we know that tangent theta equals to 1 over root 2. So the only thing that is left to find is to find out the value of AB, and then we will find out the value of the radius of the small circle, because the radius of the small circle equals to AB times tangent theta, and we found out that tangent theta equals to 1 over root 2. Okay? So in triangle EBO, the right triangle, triangle EBO, we know that tangent 2 theta equals to OE over OB, or EO over BO. And we know that EO is the radius of the semicircle, and the BO is the variable that we want to find out. So we know that tangent 2 theta equals to 2 times root 2. So we substituted tangent theta by 2 times root 2, and we found out that BO equals to 3 over 2 times root 2. So we found out the value of BO. And in the right triangle, triangle APO, we know that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AP square plus PO square equals to PO square. But PO equals to MO minus MP. PO equals to MO minus MP, that is to say, PO equals to capital R minus small r, and capital R equals to 3, so PO equals to 3 minus R. And AP equals to small r, so in total we got that R square plus AO square equals to 3 minus R square. And by solving this equation, we found out that OA equals to the root of 9 minus 6R, and we already found out that BO equals to 3 over 2 times root 2. And we know that AB equals to OA minus BO. AB equals to OA minus BO. And we have the value of BO, and we have also the value of OA. So we substituted OA by its value, and we substituted BO by its value. And we found out the value of AB. AB equals to this expression, and we have already found out that tangent theta equals to 1 over root 2. So we can substitute AB by this expression, and we can substitute tangent theta by 1 over root 2 in this equality. Okay, so we solve this equality that R equals to AB times tangent theta, and we got to a quadratic equation that 16R squared plus 72 minus 63 equals to 0, and we solve this quadratic equation, and we add two answers possible, and the only answer that is correct is that the radius of the small circle equals to 3 over 4 units, so the radius of the small circle equals to 0.75 units. Okay, the radius of this small circle equals to 0.75 units, or to 3 over 4 units. Okay, thank you very much.